Okay, I'm going to do an example of a related rate problem. What we're looking at is a 10-foot ladder up along the side of a wall, where h is the height from the bottom of the wall to where the ladder is touching it. So, that's my distance h. Theta is the angle between the ladder and the floor. Assuming that the floor and the wall are perpendicular, which means they're going to form a 90-degree angle, we're going to allow our ladder to slide down the wall. Now, the question I'd like to know is, how fast is theta changing per second if the height of the ladder along that wall is dropping at 2 feet per second? So, what are we really talking about? The height of the ladder is changing with respect to time. That is dh dt equals, in this case if it's dropping, it's going to be negative 2 feet per second, which means h, the height of the ladder against the wall, is in fact a function of the time. What I need to do is find a mathematical formula that connects my angle to that height. Notice that the sine of theta equals h over 10. I'm now going to take the derivative of both sides of this formula with respect to time, because clearly there is a relationship between theta and height is clearly a function of time, which means I can apply the chain rule or U substitution, if you will. So, what I'm going to do then is, if I want to take this derivative with respect to time, then the derivative of, I'm going to go ahead and move the 10 over. And I'm going to take this derivative. So the derivative of sine is cosine of theta times, in this case, d theta dt, which means that there is a derivative with respect to time, but theta is not equal to time, so I need that two-step with the chain rule. And that is going to equal the derivative on this side with respect to time. Now, the derivative of h would be 1, but I need that second rule because h isn't time for my chain rule, dh dt. So I'm applying the chain rule both on the left side and the right side, because neither the left side nor the right side contain the variable t. But clearly, theta is a function of time as well as the height. So, now, what do I know? I want to find how fast my angle is changing, which by definition then would be d theta dt. So, what I can do is let d theta dt equal dh dt divided by 10 cosine of theta. And I said I wanted to find this, did I say a specific height? Let's say when the height h is 6 feet. Now, right now, what do I know? I know dHd theta is -2.
Oh, I thought
That's DH.
DH.
dHdt, I'm sorry, is -2. I do not know what the cosine of theta is just yet. So, what is cosine? Well, cosine, I'm going to call this side A, would be, what, A over 10? So what I'm looking for right now is cosine. And cosine of theta is A over 10. To find that amount, I need to know what A is. So, I'm going to use the Pythagorean theorem, which gives me h squared plus a squared is 10 squared, or 100. The length of the legs of a right triangle squared, sum is the hypotenuse squared. I know what h is, 6, so h squared is 36. Which means that a squared is 64. A is going to equal not plus or minus 8, because there is no such thing as a negative length in the dimensions we're going to be working with. So I'm going to assume that the length along that wall is 8 feet. If I know that, then I know cosine is 8 over 10. Come back, d theta over dt equals -2 over 10 times 8 over 10. Sorry about that. D theta dt is -2 times 10 times cosine, which is 8 over 10. 10 reduce out, giving me -2 over 8, or -1/4, and this is going to be in radians per second. So 1/4 of a radian per second.